Welcome to Exam Review Additional Problems for M105 or 105M. These are a few additional. This is the test was expanded a little bit, so I thought I'd add a few more problems just to make sure that you had some practice with the slight variations that are in these newer problems. Before I do the first problem, I want to draw your attention to this here on the first page. This is going to be on the first page of the exam. It says no credit will be given for answers only on your final exam. Well, if you just circle the answers, you're not going to get any credit for it. You must show calculations and/or a short explanation to justify your answer. So, for instance, if you know that a certain one is the answer, you have to explain why, at least. Or if you figure it out with your calculator, you have to explain the steps you chose on your calculator so we can verify that you actually understand how to do the problem. Either that or just, solve the problem right there on the sheet. If when I give the test, I think I'm going to copy it one-sided so you could use the backs, and so then you just put an arrow or give an explanation saying, oh, look here, so I know what to look for. Number 1, solve the equation, round to the nearest tenth if necessary. Now, when we get done with the problem, we got to round to the tenth because we've got to follow directions, right? Though if you look at the answers, they're all rounded to the nearest one, so I'm not sure. Anyway, okay, so you should round it to the nearest tenth if you don't get the same answer that's here. I'll always give credit for the things that you do right. You don't have to get the whole problem right, though that's preferred, obviously. Okay, if an object is propelled upward from a height of 32 feet at an initial velocity of 64 feet per second, then its height after t seconds is given by the equation h equals a negative 16t squared plus 64t plus 32, where h is in feet. After how many seconds will the object reach a height of 96 feet? Now, this is just a kind of a plug-in problem where we plug in and then solve it, right? Solve for, in this case, t, which is going to be the seconds. In the beginning of it, it says, if an object is propelled upward from a height of 32 feet at an initial velocity of 64 feet per second, then its height after blah, blah, blah. So it could give you the feeling like you've got to plug that 32 and that 64 in somewhere, but notice they are really already in the equation. The 32 and the 64 are in that equation already. 62 feet per second and that height above the ground. So it's not asking you to figure that part of it out. It's saying, all right, what about if it reaches a height of 96 feet? How long will it take? So we just equal this whole thing to 96 feet. So we're going to get 96 equals a negative 16t squared plus 64t plus 32. Okay, so this looks a little weird. Okay. Alright, so we're going to add a negative 32 to both sides. Or we could add a negative 96 to both sides. I guess I should have done that instead. Alright, stop. Okay. We'll add a negative 96 to both sides. Makes more sense, right? Okay, so that'll give us 0 over here. Now to make it easy on myself, I'm going to divide both sides by a negative 16. Since dividing the left side by negative 16 still gives me 0. I won't even bother with that. So we've got 0 over here, and we've got t squared minus 4t plus 4. Okay, and then we have to factor that, some number that multiplies to 4 and adds up to negative 4, which would be a negative 2. So it would be t minus 2 squared equals 0. Then we equate t minus 2 to 0, and that becomes t equals 2. Since it's t minus 2 squared, both factors are t minus 2 that equals 0, so we just need to do one. So it's 2 seconds, which is C. Number 2, we have equation made out of rational expressions being like fractions. So just like in a fraction problem, we have to find a we're going to look for a common denominator. Let's say if we had a problem like this, say we had 9/3 minus 7/6 equals 3x over 18. Okay, yeah, that'd be a good one. Or even better yet, to go with the theme, $36. Okay, so we have to find a number that we can multiply each of these equations by to eliminate the fraction part, right? So on this one, 36 is our number because 3 and 36 will divide into 36. So we would multiply both sides, the whole thing, by 36. And this is one way of showing it. Okay? So 3 goes into 36 12 times, so we'd have 12 times 9. 6 goes into 36 6 times, so it would be a minus 6 times 7. And 36 goes into 36 1 time, so it would be 1 times 3x, or just 3x. Okay, then we solve that. 9 times 12 is 108, minus 42 equals 3x. See, and then it becomes a simple problem. We've eliminated the fractions and so on. So we do the same thing with rational expressions. We find a common denominator that will take care of everything. So m minus 2 and m plus 2 are factors of m squared minus 4, because m squared minus 4 is a difference of two squares. The two squares being m minus 2 and m plus 2 as factors. So we multiply the whole thing times m squared minus 4. Let's see, times 9 over m minus 2 minus 7 over m plus 2 and over 4 divided by m squared minus 4. Also, we have to look at the original equation, and we have to keep in mind that we can't use numbers that will make this thing dividing by 0. So, for instance, we can't use, in this situation here, we can't, where m minus 2 would equal 0. That means m equals 2. So m can't equal 2. In this situation, it can't equal negative 2 either. And then over here, either of those squared. So if m is 2 or negative 2, then these cover that one too. So m just can't be 2 and negative 2. So we just have to keep that in mind while we're multiplying through. Okay, so we multiply m squared minus 4 times 9 over m minus 2. And that makes this cancel out into that. And what that leaves us on top, though, is it leaves us m plus 2 times 9. In the second one, dividing m plus 2 into m squared minus 4, it leaves us with m minus 2 times 7. And in this one, well, it cancels completely, you know. M squared minus 4 into m squared minus 4 is 1. So we don't have to put anything, but 1 times 4, just 4. Okay, so now we solve for this. This is a 9. Okay, so we get 9m plus 18, and then here we get a minus 7m minus 14, and here we still have just 4. Now notice what I did here. Because this is a subtraction here, I'm being very careful with that. I'm saving that negative here, so now I'm going to multiply through with the negative before I start combining like terms. So I make sure that I apply that negative to both those numbers. Alright, so this simplified is 9m plus 18 minus 7m plus 14 equals 4. Okay, so now we combine like terms and we get 2m plus 32 equals 4. Okay, add a negative 32 to both sides, we get 2m equals 28, and negative 28, adding negative 32, and then divide by 2, m equals a negative 14. And negative 14 is not 2 or negative 2, so it's fine, that's our answer. And the answer C is correct. Number 3. At a fixed temperature, the resistance R of a wire varies directly as the length L, and inversely as the square of its diameter D. If the resistance is 1.08 ohm when the diameter is 1 millimeter and the length is 270 centimeters, what is the resistance when the diameter is 4 millimeters and the length is 1800 centimeters? Okay, so this is one of those variance problems, and we know the first thing we do is we find K. So we have to make our, well, the first thing we do is we write our general formula. So the first word in this, besides temperature, at a fixed temperature, the resistance, it's the resistance of the wire that varies with the other things. See, so we'll write our formula, resistance equals, and it'll be K times something. Okay, so the resistance of the wire varies directly as the length, so it'll be K times L, and inversely as the square of its diameter. So the diameter goes under here and it's squared. Okay, so it's directly with the length, inversely with the diameter squared. Now, it says, if the resistance is 1.08 ohms, 1.08, and when the diameter is 1 millimeter, so this would be 1 squared, and the length is 270 centimeters, so our K is here, and we'll put 270 here. Then it says, what is the resistance when the diameter is 4 millimeters and the length is 1800 centimeters? So we're going to be looking for the resistance, and we'll find the K. We're going to find the K right here. Okay, so then we'll stick it, once we have it, we will stick it in there. Okay. So it says, what is the resistance when the diameter is 4 millimeters? So it would be 4 squared, and the length is 1800 centimeters. So that'll be times the K, 1800, once we find the K, right? So I was trying to get black. Alright, so we solved this one first to get our K. Okay, so 1 squared is just 1, so actually we have 1.08 equals K times 270. So we could divide both sides by 270, and we get 1.08 divided by 270, and that's going to equal our K. So K equals 0.004. We'll stick it in here, 0.004. And now we can just do this whole calculation on our calculator, using parentheses on the top and then dividing by 4 to the second power, 4 squared. And what we get is 0.45 ohms, because resistance was in ohms. And that's the answer. And that is letter D. Number 4, rationalize the denominator. Assume all variables represent positive numbers. So that means we want to get the denominator out of the radical. And we could start off by doing that. We could multiply, for instance, we could multiply the top and the bottom of this. We extend the radical, or we could do it on the outside, but this is easier. We could multiply y to the 5th over y to the 5th times this thing, and that would rationalize our denominator here. But since there's a number of things that can actually be taken outside the radical, because we can find the square root of them, let's do that first. Okay, so we have the negative square root of 50x cubed divided by y to the 5th. Okay, so let's factor this out a little bit before we take the square roots of a few things. So 50 is 2 times 25. We know we can take the square root of 25. And then x cubed is x squared times x. So we can take one of those x's out. Y to the 5th is y squared times y squared times y. So we can take 2 of those out. So let's do that. I guess I can do it here. Okay, so we're going to take out a 5 and an x out of the top, and that will give us a 2x left. And then on the y's we can take y squared out, and that leaves a y inside. Okay, so now we're going to rationalize our denominator. Let me rewrite this first. Okay, I'm going to just extend this, because I like to do it inside, but you can do it on the outside too. But you'd have to multiply by the square root of y over the square root of y instead of what I multiplied by. Okay, and I'm going to get rid of this one. Alright, so this equals 5x divided by y squared times the square root of 2xy divided by y squared. Okay, so now we can get the y squared out of the radical, but it's still going to be the denominator. The square root of y squared is y. So our problem now equals 5x divided by y cubed times, well, we could put this on top if we wanted to now, square root of 2xy. I did forget one thing, the negative. Of course, it's all still negative. Should have brought that all the way through here. What reminds me is looking at the possible answers, and if you'll notice that the answers for number 4 are all negative. So that reminded me, oh, I forgot all about the negative sign. And that helps to have multiple choice because you can kind of see what are likely answers. And so you'll know immediately whether you're way off or not.